Today we're going to start by looking at place value. I have a blank place value chart here, and I'm going to begin by labeling the different places. So you always look for your decimal point, that's key. And the first number to the left of the decimal point we know is our ones place. And then it goes tens, then it goes hundreds. We move on to the next chunk here. This would be thousands. And here's where you'll start to see the pattern. Then we have 10,000s, and 100,000. And we finish it off with the millions. So I finished up to the millions place, and then I'm going to come to the right of the decimal. Now there isn't a 1th place. It just sounds weird. So it starts with tenths, hundredths, then we have thousands. I like to think of this as the TH side. It is the exact same thing that we have in our whole place value as we do our decimal side. So this is kind of our TH side. It's a mirror image with the exception of the ones place, and it will just continue on and on and on. The next would be 10,000ths, and then 100,000ths. Now while we're looking at relationships, I would also like to go back and look at a little pattern that we have. This is our ones place, tens place, hundreds place, and then this is our thousands chunk, if you will. Okay, and then that pattern starts over. It's 1,000s, then it's the 10,000s, 100,000s. So it's a repeating system that just counts by ones, tens, hundreds. And then it goes to the next section, which would be the millions, which would continue on as millions, 10 millions, 100 millions. Now, if we look at this relationship more closely, we will actually, let me back up there for a second. If you think of money, all right, I always like to go back to money. Everybody likes money. We know how money works. If you think of a 1, how many ones does it take to get a $10 bill if you wanted to trade? You would need 10 ones to get to a 10. So to go from the ones place to the tens place, you need to times it by 10 to get here. And same would be if you have 10 tens. That will take you to the hundreds place value. Now, hopefully you've been fortunate enough to get to $100. As we go further, it might just be wishful thinking. So now that we're at hundreds, how many hundreds does it take to get 1,000? If you take your hundreds, it takes 10 of them to get to 1,000, and you could start to see a pattern. We increase each place value by multiplying by 10. Another way to look at it is watch the zeros. If I just write it as a number, it goes 1. Add a 0, 10. Add another 0, it's 100. Add another 0, it's 1,000. Add another 0, it's 10,000. 100,000. We just keep adding a 0. Which, if you think about it, when you multiply by tens, that's what you're doing. When you multiply by a 10, you just tack a 0 onto the end. So place value is all about tens. As you go from the ones to the tens, it's an increase by multiplying by 10. Which then we would write that number by adding a 0, and almost forgot, one day maybe we'll get there, would be $1 million, which would be adding a 0 to the 100,000, or it takes 10 100,000s to get to $1 million. I just mentioned that we can, as we go across our place value board getting larger, what if we go backwards now? What if I'm at $1 million and I am going to go to 100,000? If we do the opposite to go to the right to make our number smaller, we divide by 10. Whenever you divide by 10, you're actually taking a 0 away. I almost forgot, if we want to show what tenth and hundredth and thousandth look like as a number. Again, like I said, we're dividing as we go smaller. So if you think of what is 1 divided by 10, it would be 1/10. And then 100th looks like this. And 1,000th would be 1 over 1,000. Again, it follows that same zero pattern, except now on the TH side it's a fraction. So it would be 1 over 10. Add a 0, 1 over 100 to that bottom number. We had another 0 to the bottom number, now it's 1 over 1,000, and that pattern would keep going on and on. The easiest way to explain and understand place value is to look at expanded form, or what we call expanded notation. But we are going to, you see the root word here, expand means to stretch out, and we're just going to stretch that number out by place value. So 948 and 1/10, we can split it up and look at the value of each number. That 9 really means 900, plus the 4 actually means 40. The 8 in the ones place means there are 8. And the 1 means that there is 1/10. Okay, now this is how we typically would write that. This is how when we've practiced up until 5th grade, this is how we've done expanded notation. Okay, so let's look at our next number. We have 1,748. That 1 is 1,000, plus the 7 really is a 700, plus the 4 means 40. Having quite the time with my addition symbols here. And the 8 in the ones place means it's just an 8. And we look at our last one, it's our largest number of the bunch. Means it's going to be extra expanded here. Better start down here. So that 1 means 10,000 plus 4,000. The 6 is really 600 plus 4, but it's not just a 4, it's a 40. The 2 is a 2, and then we have the 9 is 9/10, and see if I can fit it, 0.08. Okay, that is how we would do expanded form or expanded notation. We'll let you in on a little secret. We are going to take that a step further. I always tell my 5th graders that, we do the same thing in 5th grade as we've learned all along. We just learn new ways to look at it. We will actually start to look at, and I'll give you a little sampling of what I mean here, of another way to write expanded form so we can get a better grasp on place value. So 900, we're going to break that down. That's really the same as saying 9 times 100. That means there are 9 hundreds. And 40 is really 4 tens, or 4 times 10. Then we move on to our 8. That means there are 8 times 1, or 8 ones. And lastly, it means there is 1/10. And sometimes we like to put parentheses around just so we can chunk everything together. And that is another way that we can show expanded form or expanded notation. But you can see the importance of understanding place value and how it applies to numbers. It helps you with expanded form, just like on the flip side, expanded form can help you with the place value. All right, so on this side we're going to go to the application phase. We're going to look at our numbers that are the same. So here in this number we have 6,652. And we are looking at the 6's here. So we could say that the 6 in the thousands is, first we need to ask ourselves, is the 6 in the thousands bigger or smaller than the 6 in the hundreds? So if we expand this out a little bit, you could say, well, this is 6,000 and this one is 600. So that should help us see that the 6,000 is bigger. And now we are looking at how many times bigger is the 6,000 than the 600. So if you remember back to our first slide, we said that to go from one place value to the next, so to go from the hundreds to the thousands, it's times 10. Okay, so we could say that the 6 in the thousands is 10 times larger than the 6 in the hundreds. All right, which with our example I hope makes a little bit more sense. So the 6,000 is 10 times bigger than the 600. Now we're going to move down to our next problem here. We have 7,897. Now we're looking at the sevens. Same thing that we just did above, we're just looking at a different number and different place values. So again, let's take a look at this. Our 7 in the thousands equals 7,000, and our 7 in the hundreds equals just 7. So it should be pretty clear to see which is bigger. All right, our 7 is way smaller than our 7,000. All right, so now this one gets a little trickier. How do we write, so our statement is the 7 in the ones place is, now we know it's 1,000 times, it's 1,000 times smaller than the thousands, or we could say it's 1,000th the size of the thousands place. So you could say the ones is 1/100th the size of the thousands place.